Welcome back. I am Ms. Killen here at MPB. We are going to dive on into more of our Unit 6, Introduction to Quadratics. We are looking at Lesson 2A today, where we are factoring quadratic expressions. I can factor using the distributive property. So let's go and see what these expressions show us. First thing I want to do is I want to review, going back to looking at some of those concepts of our linear functions. We had our box method and we had our FOIL method. Okay, now with the box method, remember we were multiplying from top to side in our multiplication of top to side, and then we added diagonally. So let's go ahead and look and see what that looks like. So 2x times 4x would have given me 8x squared, because x times x would be 2x, or excuse me, x times x would be x squared. And then a positive 6 times 4x would give me a positive 24x. 2x times a positive 5 would give me a positive 10x. Positive 6 times a positive 5 would have given me positive 30. So now that I have multiplied from top to side, I'm going to add diagonally. Corner to corner, I have 8x squared. Corner to corner addition, I'm going to get plus 34x, and from corner to corner, plus 30. And that is how I got my quadratic equation using my box method. So now let's go ahead and look at that FOIL method, which we've also learned as double distributive. We've learned the steps for this box method. We had our F, which is our first two. The next one in our FOIL, we had O, which was our outer two. And I think when I gave us our list of first, outer, inner, last, I think I misspelled the word. So I do want you to know I can spell outer, so I do apologize for that. 2x times 5 is a positive 10x. Our next one is inner. It's the two inside of everything. So 6 times 4 is a positive 24x. And then we have our last, which is our last two. The 2 and the 1, that's the 5. We multiply them and we get a 10. Remember, we always put like terms together. So I have a 10x plus a 24x. So my ending numbers would be now we have it. We had our box. We have our FOIL. So let's go ahead and see how we're going to use this information to use our quadratics. So we can use these same methods to factor the GCF out of expressions. Now, we need to make sure we understand what that means, GCF. Now, we've heard it before. We should have learned it before. But what did we say GCF meant? Greatest common factor. You need to make sure that you are remembering greatest common factor, what everything has in common. That whole thing is common, the greatest thing they have in common. So let's look. So when I have 6x to the third minus 16x plus 4x, I want to see what I have. Sorry, I didn't put my 2 there. So I have 6x to the third minus 16x squared plus 4x. I want to know what each one of these terms have in common. Well, the first thing I'm always going to do is look at my numbers. So when I have this one here, I always want to look at my numbers first. I have a 6, I have a 16, and I have a 4. Now, what do I notice about all three of those numbers? They are a what? Exactly right. They are even numbers. So I know that what number will go in every single even number. Exactly. I can pull out a 2. Now, let's look at our variables. Now, this is something that I have been showing my students for years. I have 3 x's that's being multiplied to each other. I have 2 x's that's being multiplied here. And then I just have the 1x. For me to figure out what the greatest common factor of my variables are is how many times can I circle a x in all of them. And so I can pull out 1x out of all 3 of my terms. So I'm going to take an x out. Then I'm going to put what I have left. So let's see. 2 divides into 6 how many times? 3. X to the third minus an x would give me x squared. Good job. I have 2 divided into 16. The negative 16 is going to be an 8. X squared minus an x is going to be 1x. And then my last term, I'm going to have 2 divides into 4 2 times, and I take off those x's, and I am left just with the 2. So there is what is left after I take out that greatest common factor. You are dividing out your numbers, and you are subtracting out those x's. Remember, how many times can you circle the same number in all of the terms? Good job. Let's look at the next one. Remember how we made equivalent expressions using both methods? Remember how we had an expression and we did something to that expression and we made something that was equivalent to it, meaning the same? Let's go ahead and review that. Let's use our FOIL for our first one. First, we have our f, which is our first, which is 6x squared. My outer ones, minus 12x. My inner ones, plus 12x. And then my last ones, which are 24. Okay, so I have to put my like terms together. Negative 12 plus 12 is 0. So I have 6x squared plus 24. So looking at this, I think Ms. Killen made a mistake on a slide back. So let's go back and look at those slides. Over here, I put, right here, I did my last, but I didn't do my last. I did my outer again. So I should not have gotten that number. I should have gotten these 2 right here should have been multiplied. So 6 times 5 would have given me 30. That's how you can possibly get messed up when you do those first and last. So you always want to make sure that you know my first 2 terms and then my last 2 terms are the ones that are at the back of both of my terms. So that's a good teachable moment there that shows us we've got to make sure we know what those last terms mean. That was a good catch. That was a good catch. So let's go back and make sure that we've done this. So when I did my last terms, it was a 6 times a negative 4. So then I should have gotten my negative 24. Those are very good catches. You've got to make sure that you're careful with your positive numbers and your negative numbers, because when I multiply a positive times a negative, I'm always going to get that negative number. So that was a good catch. Let's try our box method now. So remember, with my box method, I'm going to go ahead and draw my box and split my terms up. So I'm going to have 7x plus 3, 2x minus 1, multiplying my top to my side. 7 times 2 is 14. X times x is x squared. 3 times 2x is a positive 6x. 7x times a negative 1 is negative 7x. 3 times a negative 1 is going to give me negative 3. Then I am adding corner to corner. So I get 14x squared plus negative 7x plus 6x is going to give me negative x, and then I have that negative 3. Make sure you are looking at your math. Make sure the math is adding up. We want to always make sure that we get those correct numbers. All right. Now, let's look at factoring these equations. This is kind of like going backwards. Now, we've put our binomials together and gotten a trinomial, but what if I'm given the trinomial and I want to go backwards to the binomials? This is what it's like. We're going backwards. All right, so let's look at this. I see that I have my ax squared plus my bx plus my bx again. So, Ms. Killen, when I have two of the same, what do I need to do? You always reduce. Always put like terms together. So I'm going to end up being able to put those together. Well, when I put them together, what do I get? I get 2x squared, what? Minus 2x. So now that I put all my like terms together, do I have a GCF? Anything that I can take out of both terms? Well, we always start with our numbers. So I know I can take out a 2. And when I look at my variables, I have one variable in common. So then I'm going to put down what is left. 2 divided by 2 is 1. You don't have to put the 1. If you need to see the placeholder, then you can put that. 2x, or x squared minus that 1x. I'm left with an x left. 2 divided by 2 is what? 1. And then that x and that x are canceled out. So I am left with 2x, x minus 1. And that is how I factor that trinomial. I went from a trinomial, reduced as much as I could, put like terms together, then took out my GCF, and I'm left with 2x and then x minus 1. You always want to make sure that you reduce. Always, always, always make sure that you reduce or take out like terms. All right, now stop. Let's look at this. To tell what the new binomial's operations will be, we must follow these hints. If I have an equation that looks similar to this, and I'm going to put my quadratic formula up here. If the second operation, this is the second operation, is positive or a plus sign, then both of my new binomials will be the same as my first. So if I had one that looked like this, it would look like this. So then it also says if I have one like the bottom, x squared plus x minus 2, and my second one is a subtraction, then both of my binomials are going to have different operation signs. One's going to be a positive and one's going to be a negative. Depending on what you're trying to get, depends on what is going to be positive and what's going to be negative. On your notes page, you want to make sure that you're writing these two hints down, because this is what's going to be crucial when we start having to find factors and then add to get this middle number or subtract to get this middle number. So you're going to want to make sure that you've got these in those notes pages. All right, so let's go ahead and look to see what these two hints are going to help us with. First thing we do, we have looked at GCF. Now we're looking at factoring a trinomial with my a equals 1. So remember, ax squared plus bx plus c. So now what I'm going to do is I'm going to factor this trinomial. The first thing I need to do is get the factors of c. Well, my c is a 4. My factors are 1 and 4 and 2 and 2. You may be asking yourself, Okay, what are factors again? Factors are numbers that multiply together to give you a product. That's a factor. Good job. That was a good question. So now that I have found my factors, I need to know which ones of those factors, which pair of factors will add to give me a positive 4. Exactly right, my 2 and 2. I pick the pair that will do the last operation to get my middle number or my b, which is my 2 and 2. So what I'm going to do now is I'm going to start creating my binomials. All right, so I know that I am going to use my 2 and I'm going to use my 2. This second operation tells me that both of my binomials are going to have the same as the first operation. Now you're probably saying, Miss Killen, what's going to go next? Next, I've got to figure out the factors of x squared that will give me x squared. So what do I multiply together to get x squared? You're exactly right, x times x. And that is my 2 new binomials. I factored my trinomial and got my binomial, 2 binomials. Now what we also need to remember is when I see something that's the exact same, I can write it in a reduced way. So x plus 2 times x plus 2, I can write it like this, x plus 2 squared. How we always write x times x could equal x squared, I can do the same thing with binomials. X plus 2 times x plus 2, I can write as x plus 2 squared. So that's something that we need to remember. All right, we want to make sure that we've got those on our notes page. Now, let's do some practice. I want to factor number 1. So, like we have used on the other slide, I am going to find the factors of 24 that will subtract to give me negative 10. So let's look. Factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. So which pair can I manipulate or can I subtract to get a negative 10? Exactly right. So I'm going to build my 2 binomials. This second one is a subtraction, so I know one's going to be a positive and one's going to be a negative. So how am I going to put that 2 and that 12 in there to show that I subtract and get my negative 10? Positive 2 minus 12 gives me a negative 10. And then factors of x squared that I can multiply together to get x squared is going to be x and x. Good job. So I took my trinomial, factored it, and got my 2 binomials. Let's look at the next one. So now I have the factors of 25 that will add to give me a negative 10. So let's look. Factors of 25. 1 and 25, 5 and 5. So which pair am I going to add to get a negative 10? Exactly right. So I'm going to build my 2 binomials. My second operation is a plus sign. So both of my binomials will have the same sign. I'm going to put 5 and 5. And then I have the factors of q squared that would give me q squared, would be q and q. Since they're the exact same binomial, I can write them, yes, exactly right, q minus 5 squared. Good job remembering. All right, let's look at number 3. Let's see what we got here. I need the factors of 9 that will add to give me positive 6. So let's look at some factors. So I've got 1 and 9, 3 and 3. Which pair could I add to get that 6. Good job. So I'm going to build my two binomials. That second operation shows me that it's plus, so that means both of my binomials are going to have the same as the first one. I'm using 3 and 3. And then the factors of t that give me t squared, the factors of t squared that give me t squared are t. When I see that they're the same, I can rewrite them. Is t plus 3 squared. Good job. Now let's look at this last one. So I need to get factors of 15 that will add to give me a positive 8. So let's look at some factors. I have 1, 15, 3, and 5. Which pair will add to give me a positive 8? So I'm going to build my two binomials. That second operation sign, which is a plus, tells me that both of my binomials are going to have the same as the first. I have 5 and 3. The factors of b squared, yes, b and b. And that's it. Check your work to mine. All right. Thank you so much for coming to join me and working here hard with these quadratics. Thank you. I am Ms. Killen. Have a good day.